Okay, so good morning, everybody. Well, good morning, good afternoon, good evening. This is a virtual conference, so you could all be from anywhere. My name is Jamie Coleman. I'm a developer advocate for IBM based in the United Kingdom. And today I'm going to be talking about the magic of containers and how they can enable you to do even better testing and kind of merge your production and your development testing environments into one. So let's get started. So what we're going to be covering today, first we're going to talk about how kind of containers began, talk about some of the problems we're trying to solve with containers, a little bit about testing with containers, and we'll talk a little bit about what the Testcontainers framework is. Then we'll talk a little bit about what the MicroShed testing framework is, if you haven't heard of that. Then I'm going to talk a little bit about OpenLiberty, which is an open source runtime, and how it works really well with Testcontainers and MicroShed testing. I'm praying to the demo gods this morning, so hopefully they listen to my prayers, and I will provide you an interactive demo. And then I'll go through a little overview, provide you some links, and everyone can ask some questions at the end. If you do have any burning desires to ask any questions as I go through this talk, feel free to put something in the chat. I may or may not see it, but I will get to any questions that are asked at the end of this talk. Okay, so like I said, in the beginning, let's go through a bit of history here. So in the beginning, well, okay, maybe not quite the beginning, but in 1979, the Unix v7 was introduced. And this is when the ch root system call was introduced. And this kind of changed the root directory structure in the file system on Linux. So this was kind of really the first step towards what we now know as containers. So moving on from there, in 2006, Google created something called process containers. And this was done in 2006 by Google. And this basically was designed for limiting, accounting, and isolating resources, so such as CPU, memory, disk, input and output, and network, of a collection of processes. So this was really kind of the second kind of step to actually implementing what we now know as containers. Now, I don't know if anyone's heard of this project, but in 2006, LXC, or Linux Containers, was really the first kind of implementation that you could quite easily use as to what we now know as containers. So this was a complete implementation of Linux Container Manager. It was implemented in 2008, and it's using the C groups that Google introduced in 2006 and the Linux namespaces. And it works on a single Linux kernel without requiring any patches and any updates, which was amazing. And then 2013, as we all know, this is when Docker came around. And in my opinion, Docker really made containers quite simple to use. They created a really good command line interface that made it very simple. They created their own registry, so Docker Hub, which allowed you to get the latest applications and runtimes, etc., and all the different components you need quite simply. So this was really, really a big thing. Now, Google, and I think a lot of other companies, saw that this was going to be a very, very big thing. And in 2014, the community, backed by Google, basically created an open source project called Kubernetes. I presume everyone's probably heard of Kubernetes and Docker, etc. But Kubernetes is basically a container orchestrator, because while using containers are great, it's okay when you've got 1, 2, 5, maybe 10 containers. But when you're looking at hundreds of containers, managing these things can be quite difficult, especially when now we're in a new world of microservices and we've got lots of tiny little services running around as opposed to just big, big applications. So Kubernetes basically changed the game and made containers a lot easier to manage. So there's your very brief history of containers. You probably already knew a lot of that information anyway. So let's move on to kind of what containers provide. So first of all, they provide virtualization from an operating system level. They're nice and lightweight, faster startup. For example, if I was running 10 OpenLiberty servers on virtual machines on my laptop, I'd probably start running out of steam at about 10 virtual machines, maybe 15 virtual machines, even if I created them quite small. Whereas I've actually had hundreds, or about 100 containers running with OpenLiberty on my laptop using containers. So they are a lot more lightweight than virtual machines, etc. And the startup time is a lot quicker. So with an OpenLiberty container, I can start it up in seconds, as opposed to a virtual machine, which could take minutes. The great thing, which is why they're very useful for testing, is they're portable. That's the whole point of containers. You basically have it all in an image, and then you can move those images. You can send them to people, store them in repositories, registries, for other people to pull down and use. And the configuration is portable as well in the form of a Docker file. So you can hand this Docker file to a colleague. He can then just run the Docker build, which will pull down what he needs and build his container. So nice and portable there. Another great thing is the idea behind containers is they should be able to run anywhere. I know there are some architectural decisions you have to make when you build containers, but if the runtime or the applications and everything you put into the container supports the different architectures, then it should be quite easy to build new images for different architectures. Of course, isolation. We want to have lots of things running on the same machine, but we don't want them interfering with each other. So containers are really great there. And what also do they provide? Well, complexity. Okay, so I don't think containers have really introduced complexity to our lives. If you say you swapped a container for a virtual machine, I think they're probably as complex as each other. I think the complexity comes more from the architectures we're using these days. So microservices, functions as a service. Whereas before we would just have our one big application running on a virtual machine. I mean, you can still do that. You can have a monolith running in a container, running on the cloud or wherever you want to run it. But I think the complexity really comes from the fact of the architectures we're choosing. And for good reason, they are a bit more complex because they can help with lots and lots of different things. So what does the magic of Kubernetes provide? A lot of you probably already know this, but just to kind of go over it, just for those who don't, automatic rollouts and rollbacks. So we can roll out new versions automatically. We can roll back versions if we have problems with our applications. We can automatically scale containers, which is amazing. So if we have, say, an application which is getting a lot of traffic, Kubernetes can scale that up, which means, hopefully your users and your customers don't have any issues trying to hit one of your services. Health monitoring is something Kubernetes provides, which works really well with OpenLiberty and lots of other runtimes. So we can check the health of our applications before we start serving them requests. Declarative management, so we can declare what we need in our POM files in YAML, not always everyone's favorite thing to write in, but yes, that is what Kubernetes uses. And the idea is also Kubernetes will run anywhere. You'll be hard pressed to find a cloud provider who doesn't have a kind of Kubernetes offering. Every cloud provider from IBM to Azure to AWS, I've used all of their Kubernetes offerings, so they will all have them. The only thing you kind of have to consider a little bit is different cloud providers have their own way of doing things. So, the process of, rolling out a new version on Azure might be different to AWS. So that's where it gets a bit complicated, especially when you're jumping from cloud to cloud. But there are ways you can avoid that by using another layer on top called, for example, like OpenShift, which basically makes the process and everything the same no matter where you're running it. Okay, so what magic can developers use from containers? So first of all, for us, isolated developer environments is important. Like I mentioned, being portable is very important. So being able to easily package up my application, put it somewhere so it can be pulled in by the test team, etc. Pre-configured images available. I think this is really a massive thing that Docker did with Docker Hub, etc. Is allowed you to very simply pull down pre-configured images to get started very, very quickly with your development. Whereas back in the day, there wasn't a massive repository of virtual machine images you could use. And even if there was, they're quite big, and then even installing them takes time. Whereas for containers, we don't have to worry about any of that. We just go and pull down the latest image and it'll just spin up and get going. Fast startup of applications, that is important, especially for testing purposes. If it's, every time we want to run a test, it takes 5 minutes to start up our application, that's not great. Especially if we're making small changes and we just want to run through our test again. So having stuff start up in seconds means me as a tester makes my life a lot easier because I can run my, go through all my tests and they get started in seconds as opposed to minutes. Great thing about containers are we don't have to pre-install all this stuff now. So databases, getting the right dependencies, making sure we've got the right version of Windows, making sure the environments got all the latest updates, etc. We don't have to worry too much about that anymore. And that's something containers do offer us as testers and as developers. Version control of dependencies, which is good because obviously we can build images, we can put them at the right version. So for example, whatever I'm using in production, I can use that same image, put that in a repository or registry, and then my local testers, so people that are running stuff locally on their laptop, can pull those down easily, and everything will be at the right version because that's what we're going to be using in production. It quite easily develop in the cloud. So yeah, I mean, there are even IDEs that run in containers these days. And honestly, I think this is where the future of development will go eventually. Right now, of course, we're all using very powerful laptops to run our builds, but cloud providers are a lot more efficient than, you know, our local laptops are at doing things. So eventually, when everyone's got a very good internet connection, I think a lot of development will be done in the clouds. But not everyone does at the moment. So for now, we'll stick with our powerful laptops, and we'll get to development on the clouds when the time comes. And true to production testing. So I think one of the big problems we have with testing is your local environment may be different to what you're using in production. I covered this very briefly a minute ago. But that can be a problem. You could have dependencies with not the right versions, mismatches, and it's very annoying that, you know, you test something locally, everything works locally on your laptop. You go and put that in your repository or your registry, that image, and then it goes through your DevOps pipeline and it gets tested and then it fails. And it's just, a lot of the time that it's just, if it's passing locally on your laptop and failing there, it's just kind of mismatches in your environment. So using containers, these portable things, trying to bring your production environment closer to your development environment is very important, and it's something that containers can help with. So back to the beginning, we had the application because we definitely didn't have the test first. Most people always write the application first, no matter what we're told. So problem with testing that containers can solve. So data access, such to databases, having to constantly have a database locally, which we have to manage. And obviously, sometimes the data is, you know, completely different to what we're using in production. So if we're using containers in production and we're using them for our host our databases, why not pull those databases down, make a copy of them locally on your laptop so you can test with the actual true data you're using in production. Integration testing is something that containers can solve. So we can spin up lots of applications, basically a whole environment with all the different services we need, and actually do testing between all of them as opposed to just testing each one individually. Because that's a lot more difficult if you're using virtual machines, for example. If I've tried to start up 10 virtual machines on my laptop and want to do integration testing between them all, that can get a bit messy, a bit complex, whereas containers, it makes all that nice and easy. Automatic updating and version control. So I mentioned this earlier. Really, all you need to do is whenever you do a test or you create changes, you can pull down the latest image that your company has stored in their registry or repository. And then that can be managed. So that can be managed in regards to updating the latest dependencies, making sure they're secure, of course. And being able to actually version control the environment, not just the application, not just the individual parts of your stack, but the actual whole environment you can actually version control with containers, which is good. And containers have this whole functionality of tags. So you put the name of container and then you put the tag on the end. So that tag can then be used to quite easily let your users know what is the latest version. You have latest, and then you can put version 1, 2, etc., etc. Avoiding complex setup on local machines. So like I said, for example, just, so having the wrong dependencies, if you're running the wrong version of Maven, I've had this before, it just throws horrible stack traces out with no actual explanation as to why it's broken. So having all your having everything set up in a container means you can just throw it away afterwards. You don't have to have all this software on your computer that you have to keep constantly up to date. You can pull down your image, do your testing, throw it away. So it's great because it avoids all the complexity of setting these things up on your local machine. And also, like I mentioned, the whole point of containers, I mean, container means it's all contained in a thing. That's the whole reason they're called that. means they're portable, so you can move them around. I could give the application I'm working on, I could give it to a colleague of mine. He can run some tests on his machine, might have a different operating system or something. So you can easily move them around from person to person and into different parts of your DevOps pipeline, rather than having to rebuild and redo everything every time. So let's get into a little bit about testing with containers. Just bear with me, I am just waking up a little bit, hence the caffeine. So as I go through this talk, you might find that I get more and more enthusiastic about what I'm talking about. Okay, so in 2015, there was a project created called Testcontainers. And Testcontainers, I love Testcontainers. I use it all the time. I've wrote a couple of articles on it. I've created some demos about this. So I think it's an amazing thing. So the problem is, at the beginning, containers had some issues. And as you can see, Testcontainers came out way after, about 2 years after Docker, and basically really containers got popular. So, for example, containers weren't really designed for testing purposes, but they do have the capacity to help in many ways. So, for example, they were never designed for graphical user interfaces, and they didn't have supports for all the different operating systems, such as Windows and Mac. Whereas now that has completely changed. Testcontainers do support all the major operating systems. They are great for testing, they are portable, and they do support graphical user interfaces now. So if you haven't heard of Testcontainers, I'm going to introduce you to it here. So Testcontainers is a Java library that provides lightweight, throwaway instances of anything that can run in a Docker container and supports JUnit. It does work with other things such as Podman. So I've just used Docker here as being the main thing that people use for containers, but it does work with other container technologies. So Testcontainers make a variety of different testing easier. So such as data access layer integration. So things, for example, talking to your databases, having them pre-built, and then being able to pull them down and run them locally rather than having to set all that up locally on your machine. Integration tests. So like I mentioned, we can spin up lots of containers at the same time. So we can actually do true integration tests where all this stuff is running and we can do testing between all the different services. It does support UI and acceptance tests, which is something that would have been quite difficult in the early days of containers, which is really amazing. So it can actually go through, and I'll explain a little bit about that in the next slide, but again, it can do graphical user interface testing, which is awesome. It has loads of different modules. So for example, if you're using Postgres, there's a Postgres module there. So rather than having to set up all the nitty gritty stuff of talking to Postgres, you can just use their module, which will set a lot of this stuff up for you. And it supports JUnit 4, JUnit 5, and things like Spock. So it's quite easy to get started with this, and hopefully I will show you in my demo today. I'm going to take a normal JUnit test, turn it into a test container or a MicroShed test, and then spin up the test just to show you how simple that is to do. Okay, so like I mentioned, it has browser testing, which is awesome. I haven't actually done much with the browser testing because when I create demos, I'm definitely not a front-end engineer. Just moving a div, just moving a text box on in front-end stuff takes me forever. So I haven't utilized this functionality as much as I would like to, but I have seen it used before and it is quite cool. So it creates a fresh instance of your browser every time. There's no browser state because it is a fresh instance, and you can decide what plugin variations you want and what browser upgrade you want. And it will even provide you a video recording of your test session, or I mean, if everything passes, you might not want the video recording, so you can just have it provide you that if you have a failed test session. But it's very cool to see how the mouse moving around and then it giving you feedback as it goes along. Like I mentioned, there are lots of different test container modules around there. These are just some of the main ones. So for databases, you've got the main things like Couchbase, DB2, MongoDB, MySQL, Postgres, etc. And then there's other modules. So there's plugins for stuff like Docker Compose, Elasticsearch, Kafka, Nginx, RabbitMQ. And things like the Kafka module are quite important because setting up test containers manually to work with Kafka can be a bit painful, a bit complex. And having these pre-packaged modules makes that really, really simple. So if there is a module supporting the technology you're using in test containers, my advice is definitely use it. As a learning kind of thing, what I would say to do is do it without the modules first. Yes, it might be a bit painful, or you could just look at the source code for the modules. All this is open source, and figure out how to do it manually, and then use one of these modules and see the difference it makes. The reason I say to do it manually is because these modules abstract away a lot from some of the nitty-gritty stuff that you have to set up in test containers. So it's worth to learn that first, because it'll give you a much better understanding of how test containers works, rather than jumping straight in to use one of these modules. And yeah, don't just take my word for it. People absolutely love test containers. The amount of people that I've spoken to that have not used it before, have created lots of projects over the last few years, and then realized it existed, tried it out, and it just blew their minds. Like, how have we not been using this for years? So don't just take my word for it. Do check it out, because test containers is really, really useful. It's really, really powerful. And it's really easy to get started with, and it's all open source. So here's a little example of some test container code. If you do want to dive into this a little bit more, I actually wrote this. There is a guide here you can go to. So if you just go to the openliberty.io website, there's a guides button at the top, and you can find any of these guides there. And essentially what I'm doing here is manually setting up test containers. So for example, I've manually set up the Postgres test container here. Now, again, there is a Postgres module, so you can simplify this if you want. But I've just kind of done it all manually just so I can kind of figure out what's going on. And again, same with the container. So the runtime I'm going to be demoing today is OpenLiberty. And with that, again, setting that up. So basically connecting them together using an environment variable, connecting them on the same network. I've got a health endpoint that it waits for, because there's no point as running tests against a runtime or an application that hasn't started yet. And then just using the log4j logger just to log to output our log somewhere. So like I mentioned, there is some extra code if you want to get into the nitty gritty of how test containers works with OpenLiberty and Postgres, etc. You can follow this link and it'll take you to a guide on GitHub. And this guide is really good. It basically goes through kind of cloud native development. It takes about 2 hours, but it goes through cloud native development from basically starting with no application to building an application to containerizing them using test containers, etc., all the way to the end, configuring them and then putting them on the cloud. So I'm going to introduce MicroShed testing. So many of you may have heard of test containers. MicroShed testing is essentially a framework that takes some of the nitty-gritty stuff away from test containers, so you don't have to manually set things up. It basically allows for true to production testing. So this is the theme I'm using in this talk, is true to production, or as true to production as we can be. And it allows for that on your local machine. So it enables you essentially as a developer to minimize the amount of test failures due to differences in your dev, test, and production environments. And then using the magic of containers, you can kind of replicate what we have in our production environment without much setup at all. And I will kind of try and show you that in the demo I'm going to run in a moment. So a small little example of how MicroShed testing code works. So at the top, we have the MicroShed test annotation, and this is required so the build knows it's a MicroShed test. So just by putting that there, Maven and Gradle, for example, will go, okay, this is a MicroShed test, treat it as a container and do whatever the extra setup I need to do. The @container annotation is required for setting up the container that we're running our tests inside. Like you can see, MicroShed testing makes it a lot simpler. So all that I'm providing here is the context root. In the demo, I'll also provide a health endpoint as well, just so the tests know. Basically, they'll probe the endpoint to make sure everything's healthy, and once it's healthy, then the test will start. The REST client annotation is needed to give us basically something to test against. So that's the REST client we're going to be testing against. And then just as you would with a normal JUnit test, the @test annotation just says basically, okay, this is the test code we're going to run. MicroShed testing also has this great thing of Sharable configuration. So it's all well and good when we're only running a few different, dealing with a few different applications, 3 different containers. But if we have a configuration, lots of applications, say for example, in integration tests that are all using the same kind of configuration or test configuration code, we can put that into a shareable configuration, into a file essentially, which all the different tests can use, rather than having to define the container, etc., in each different test. So Testcontainers works with different runtimes. So OpenLiberty is the one I'm going to be using today because I work for IBM and that's the product I work on. But you can also use things like Pyara, Micro, Server, Wildfly, and Quarkus. These runtimes all do work with MicroShed testing. So how does MicroShed work with OpenLiberty? What are kind of the benefits you might get? So we have something called dev mode, and dev mode allows you, it is available in different runtimes, but dev mode essentially with OpenLiberty allows you to start your runtime, your application, and leave it there. So you can make code changes, configuration changes, and test code changes without having to stop and start your application server. And the runtime will pick up those changes instantaneously. And the great thing with MicroShed testing is, for example, and it works also with test containers. I have tested it with plain test containers. Is basically allows you, it will pick up the changes, and then you just go back to your terminal, hit enter, and it'll spin up your containers, run your tests or your integration tests or whatever you're trying to test, and then shut them down again, and you're ready to go. And it'll pick up the changes you make in milliseconds. So it's really, really good for kind of iterative development. Because as developers, we shouldn't have to care about the runtime, having to stop and start it. We should make our code changes and then be able to just test them and make sure they work. So I will go through this in the demo today, if the demo gods are going to be happy and kind to me. But essentially, what we're going to do is we're going to be running Liberty in dev mode, and then I'll go through taking a normal JUnit test and then turning it into a MicroShed test, or which is again similar to Testcontainers. Very simple to get started. You only need a couple of Maven dependencies here, so JUnit and MicroShed testing. Or if you're using Testcontainers, you would swap out the MicroShed for Testcontainers, obviously. Minimal imports that you need to get started in your actual application code. So yeah, let me try it now and take you through running this, turning a normal JUnit test into a MicroShed test. You can follow along. I'm going to be running with a guide that we have on the OpenLiberty site. So like I mentioned, this is the OpenLiberty site is where you can go to find lots of cool tutorials, how to do lots of different things. So if you just go up to here, right, MicroShed, it's this one here. And there's even if you are into reactive architecture, there is a MicroShed testing guide in regards to doing reactive testing with Kafka and things like that. Okay, so I'm going to move this over here. I'm going to put my terminal up here. I think I've downloaded the guide already. Yep, okay, good. So I'm just going to open my code editor. My laptop seems to be going slightly slower because I'm using Zoom, but hopefully it'll be okay. So let me just get that started. Give it a moment. Okay. So in the guide, what it will tell you to do at the beginning is to go to the finish directory and just test that everything works. I have done that this morning, so I'm not going to be spinning everything up and then shutting it down again. Let me just close this. Okay, so we are in the start directory. There is 2 directories in this guide. The finish directory is what we're trying to achieve, and the start directory is basically the bare bones of what we need to get started. So like I mentioned, we're going to run Liberty in dev mode, so we don't have to care about the runtime. It'll just sit there and listen for any changes we make. So we'll let that start up. So again, we're working from the start directory today. And this is the tests we're going to edit. So this is a JUnit test. As you can see, it does absolutely nothing. It's a blank test. And what we're going to do is we're going to add to this. I'm going to show you how to turn this into a MicroShed test. And then we can run our tests in containers. I heard someone's come off mute. Did you have any questions? If not, could I possibly ask you to go back on mute? Okay, just give this a second to start up. Is it possible for the moderator to mute everybody? I am not sure how to do that, Ansu. It's okay, I figured it out. All right, brilliant. Okay, so where are we? Okay, this is starting up. Give it a second. So the first time this starts up, because I've got a completely new directory here, it's going to have to pull down the Maven dependencies. The first time we run test containers, it's going to have to pull down the Open Liberty container. Now, Testcontainers does a lot of this work for you. So essentially, Testcontainers will pull down, it knows I'm using the Liberty runtime, and it will go and pull down the latest Liberty image. And of course, you can pre-configure that to do what you want. So you can use a local Docker file, you can have it use that. And in the Docker file, you can define exactly where you're getting your image from, what version you want to use, and things like that. So it's entirely up to you how you do it. I am not using a Docker file here. I'm letting MicroShed testing take over and basically do all the parts I need, all the bits I can't be bothered to do, essentially. Okay, so while that's starting up, I'm going to, so we've got this class open. And what I'm going to do is I'm going to replace what's in this class and just very briefly explain what the differences are rather than typing this all out. So the only difference here, as you can see, is I've added some imports. The only difference are the REST client import, the MicroShed test import, which is for this annotation, the application container, which is for this annotation, and then the container itself. So like I mentioned, here what I'm doing is this is the application context route, so the URL of how we would access our application. And then we've got with readiness path. So this is kind of our health endpoint. Just make sure this is started up. So this is kind of our health endpoint. So without this, what Testcontainers could do is start trying to hit our application before it's come up and it's ready. So yeah, essentially having this makes sure that we don't have any test failures due to the application server not starting up quickly enough. I'm just going to close this and restart the application system server because it's starting very, very slowly. Usually, okay, that's because I'm running it. That will explain why it's not going into dev mode. Okay, so run basically just starts the application system, runtime. Normally, I forgot to put dev, and now it should start up in dev mode. So yeah, kind of back to the code. So nothing really changed here. This annotation will basically tell Maven that it's a MicroShed test, so treat it as so. The REST client is just what we're going to test against. So we're going to be testing against a person service, very simple application, just getting information about the age of a person and things like that and putting them into a database. So let's move on a little bit. I'm going to add in some tests now. Okay, so let's make this a little bit more complicated. So same as before, REST client, we've got our application container here, and then just some basic tests. So the first test is just to create a new person. The next one is to test the minimum size of their name, the minimum age. Then we're going to test getting a person from our application. We're going to test getting all the different people, and then we're going to test updating the age. So as you can see, Liberty is now running in dev mode. I haven't saved this file yet, so Liberty won't know that there's any changes. I'm just going to quickly run the tests. Now, this is before we've put anything in to do with MicroShed testing, so it's just going to run it as a normal JUnit test. So if I Control S this and save it, we should see this picking up that it found some new test code and it was all successful. And now if I hit enter, it will go and run through MicroShed testing. Now, again, the first time it's going to do this, it's going to have to download the dependencies it needs, and it'll pull down the Open Liberty container, start it up, wait for that health endpoint to say, yes, I'm all good, I'm ready to go, and then it will start running tests against our container. Now, by default, what it does, it will run one container and run all our tests in there. Now, what you can do if you want to do true integration testing, you can set, so basically it'll spin up lots of containers and run individual tests in each container. It's entirely up to you and how you want to do your testing, but for the sake of speed here and the demo, I'm basically just running everything in one container. So as you can see, that's all worked. We basically, it managed to test all the tests pass, which was awesome. So we're going to make this slightly a bit more complicated now. So what we're going to do is, well, we've got our test code, that's all working. Now we're going to create shared configuration. So first of all, we need to create a new file. In here, basically with the shared configuration, like I mentioned earlier, it allows us to put the configuration for all our testing in one place, rather than individually having to put it in each test. So oh, that's not where I want to go. There we go. So we're going to call this, well, first of all, let's create a file for the error path. So error path.it.java .class, yeah, Java, sorry. Okay, and in here, this is going to be nice and simple. Error path IT basically just says what we're going to put in here, basically what go wrong or the exceptions we're going to get from each of the tests. So this is nice and simple. If you have any issues with the package, don't worry. The reason I'm doing that is because I've opened this from the root directory rather than start directory, but it should all work. So that's at the end. So now we need to go and create the configuration class. So we need another class here, essentially. Yeah, we need another class here that essentially is to put our shared configuration in. So let's go and do that. We're going to call this app deployment config. Java. And then, yeah, all we need to do in there is just add in our shared configuration. Nice and simple. So then we don't have to keep defining this in every other test. I've got a feeling this should be there. Let's try and move that. That looks better. All right, cool. So now all we need to do is to use that shared configuration is go back to our original test class, which is here. And then rather than have this at container here, I'll show you. I'm just going to replace that. Now we just have to declare this annotation at the top. So obviously we've imported that annotation here, which basically defines the class that we're going to use for our shared configuration. Once we've done that, these tests will then go off and use that configuration rather than having to keep using their own one each time. And so what we're also going to do, and we can do that here as well, is as you can see, we've also defined the container in this class. I'm going to basically just use the shared configuration again. So now, hopefully, if the demo gods are happy with me, I do see something going a bit weird here, but hopefully it all runs. Hopefully it's just a package that's the problem. This will now use the shared configuration that I've defined rather than having to use that in every test. And that's kind of it for the demo purposes of this. What I really wanted to show you is how simple it is to kind of get started with using test containers or MicroShed testing. So taking a normal JUnit test and essentially, taking a normal JUnit test and turning it into a MicroShed test. And so there's not really many excuses for you not doing this or trying this technology out. So honestly, it's all open source. If you want to contribute to this, the community is amazing and they're always willing for help, as with any open source project. But it is a really, really amazing thing to basically make your lives a bit easier as developers, because we shouldn't have to keep worrying about mismatches in versions and dependencies and things like that. I know technology can be frustrating, but this should make your lives a little bit easier. Now, you're not always going to be able to use everything from your production environment. For example, databases with customer data in, that might be a bit more of a no-no, you know, in regards to you don't want essentially, you don't want people looking at that data. But for a lot of things, for dependency management, for all the other good stuff, if you're using containers in production, there is no reason why you shouldn't be taking those images or as much of those images as possible and utilizing them in your development environment. So kind of just a bit quick summary here to end. Containers are great. I love containers. My first job at IBM was actually mainframes, but my second job was in a container team. So I've been around containers my whole life, well, a lot of my career, and I absolutely think they're amazing bits of technology. And as most people probably agree, it's where the industry seems to be going in terms of where we deploy our applications these days. They do make developers' lives easier by being portable, configurable, lightweight. Rather than having to share 10 gigabyte virtual machine images, I can just push my stuff up to a registry and one of my colleagues pull it down. So nice and easy there. Containers sometimes make things a bit more complicated, but like I mentioned before, I don't think that's containers' fault. I think containers, if we weren't using containers and we were using microservice architecture or function as a service architecture and things like that, I think things would be a lot more complex. So I don't think containers actually introduce that much complexity. I think it's more the architectures we're using. And yeah, using those architectures with things like virtual machines would probably be even more complex than containers. So from that point, I would say they do make our lives a little bit less complicated in regards to some aspects. They can help, like I mentioned, they can help solve issues with production and dev testing. So trying to bring those environments as close together as possible. and they can speed up the time that you get your applications and move them into production, making our lives happier as developers because we don't have to keep getting annoyed at the fact things are failing when they're not failing on our laptops, and our customers will be happier because they can use our new innovations, functionalities, etc. a lot sooner. There are some links here to all the different technologies I've spoken about today. So feel free to go check any of those out. And if anyone has any other questions for me, you feel free to ask them now. I will check the chat. There is one message on there. But yeah, feel free to unmute yourself and ask any questions, or I will just read off the chat. And if you want to reach out to me, you can add me on Twitter or follow me on LinkedIn or whatever, and just ask me any questions and I'll be more than happy to answer. So that's about it for my session. And yeah, I will just have a quick read of the questions. So I've only got one here, and it says how to run test containers or MicroShed inside a container. For example, running on a Jenkins agent, running on a Kubernetes. That's a good question. What I would probably do, I wouldn't run, I mean, I try and avoid running containers in containers or doing any of that kind of weird stuff. So I would just essentially map in my Docker daemon from my external environment or wherever I'm running my containers and map that into whatever container I'm using. So essentially, if you're using Jenkins inside, I presume it's in a container. If you're using Jenkins in a container on Kubernetes, what you can do is map in your external Docker environment, and then spin up the tests outside of Jenkins. I'm pretty sure you can configure Jenkins to do that as well. I haven't touched Jenkins in quite a while, so it's probably moved on a lot from when I last touched it. But I'm pretty sure there are ways that you can just, if you're running stuff in a container, you can just spin up extra containers. Now, you can do the weird magic stuff of trying to run Docker containers inside Docker containers. Going back to the complexity part of stuff, I would try and avoid that if possible, just because you don't want to add more complexity and weirdness to your applications. But yeah, there are ways to do that. And if you are running in a container, and if you do want some more information on that, because again, I'm not a Jenkins expert, I used to use it a lot, but I don't anymore. Feel free to ask me and I can try and find some information about how you do that.